Hey folks, last week we looked at a change data capture from SAP table with 10 million records, and today I thought we'll go ahead and do with the table a slightly larger, that is 10 times larger, with 100 million records, and see how to extract from a range as well as do a delta, and we'll also see some of the performance. So let's get going. So we have this table. I think I'll have to log in again. This is a table which we copied over from SBook, and as you remember from last time, we have the created date and time. So we are going to do time series analysis, change data capture on this, and if I look at the number of entries, there's more than 100 million entries, 101 million plus a few. So I can extract all of it, but usually, what I've found is users, they have been extracting full so far, and now they will just want to extract, let's say, from start of this month or start of this year. So what we are going to simulate here is how to extract this data after a certain date, right? So here's what we need to do in our fabric. So this is the date-based extraction. It's pretty similar to what we have done so far. Same, source is my SAP system and destination is Azure. We are extracting, and the change here is you will see in the JSON, I'm using this table, which we just looked at in SAP. This is the table. What we are telling it that we want to extract it after 2025-0707. So that's the YMMDD format, and where time is greater than 01. So if I was to check this table for the number of records 77, and I'm checking it greater than equal to this date and this time. So my number of entries is 322. We can probably go to, yeah, so if we check all the entries after 77, I'm going to get 36,000 odd entries. So that's what we would go ahead and set up 2025-0707 greater than equal to, and let's save this. And when I run this, usually this will be scheduled either once or repeatedly. And when I run this, it will go ahead and select those entries from this 100 million plus table and just get the data which is after the given date, right? So let's wait for this. It says succeeded. It took around 18 seconds and the run is successful. What it would go ahead and do is to create an output which is this one on my Azure Data Lake. So I can't edit it because the file size will be very large, but I would have gotten around 36,000 odd entries, which I'm seeing here, right? So that's how you would go ahead and pull after a certain date. I think the idea there is you don't want to pull everything, although if you want to, you can go ahead and pull everything right from the start. I have set that in another demo last week. This is the one where we are coming late in the game and we are asked to just extract from a certain date. So that's how you would pull after a date, and then the task becomes how do we regularly pull. And I'll just go ahead to see how I can regularly pull and just the delta entries, like every day, every hour, whatever is the frequency. So I'm going to go ahead and create 2 records now in this table. These are just random entries. And to identify, I'll use my name, 5, and just put the date and time as the current date and time. So this is one record I'm creating. Save it. And then I'll create another entry so that we get 2 of those. Let's mark this also. So I've created 2 entries now. And now if I go to my delta, it's the same one which we have seen earlier. Once we have run it for a date, it knows that it has to run on a delta. Here, the parameters remain the same. I'm extracting from this table. I'm extracting everything from the last run date. So you notice here I don't have to put in a date and time. If I don't pass, it just picks up everything from the last run date. And when I run this, again, the execution with 100 million records, it's just a dev system which we have. It's not horsepower to a production scale, but it takes 14 seconds. It shows the output is generated. And if I go to my Azure Data Lake, refresh this, I have created another one here. And so first is the header row, and then it has created 2 records with this as the passenger name. So it has picked up the delta from its last run and figured out what to do with this. So this is extracted. The one thing which usually comes to mind, especially with this large number of records, is what would be the performance like? And I have been curious about this. So let's go ahead and create maybe a few more entries. And I usually use 6. So passenger name 2. Save this. I'll go ahead and create a few entries. 7. Save this. 8. Save this. So 100 million plus record, and I've created 3 more entries. And if I want to check what's the delta, run, measure the performance here. So same table, I'm just asking it to get me the delta and return it in Postman. I get these 3 records, and if you notice, the time taken is 143 milliseconds, which is not too bad. Obviously, this is just a guidance number. It should be measured in the actual system, but it gives us a sense of what's going on, what would be the uh, return time, etc. All right, so what did we do today? We extracted from a date range, or rather after a date, from a large table with 100 million plus records. We then did a delta run, and we also measured how is the response time from S4HANA system. All right, I hope you find this useful. Thanks.